Like literally 6 hours ago, I cleaned off the desk. Hey, what's happening, guys? We have got something new and cool to look at here in this box from our good friends at Owon. But as I'm opening it, I just want to tell you guys, I took my son to his first concert this weekend and we had a blast. It is so good to be getting out again into the world, being with other people, and seeing some live music. It's phenomenal. And on that note, I've joined the band yet again. This time, I'll be playing 80s hair metal music. Which is funny, because I don't have any hair. But somehow, we're going to make it work. We got our first gig in a few weeks, and I'm really excited for that. I'm also really excited for this from Owon. This is the HDS272S handheld oscilloscope. Of course, the photo is only for reference. So inside the box, we have a lovely padded, feels like carrying case. Instrucciones. Come out. And a probe, 70 megahertz. All right. So let's have a look at the old manual here. Let me see if we can glean some specifications off of here. That's nice. That's a sticker. Come on, man. Where's the specs at? You kidding me? This thing has a generator? Alright. Here we go. Specs. This is the 272S. So this is a 70 megahertz two channel scope, real-time sampling rate, single channel 250 mega samples per second, 10,000 waveforms per second refresh rate. Input coupling is DC, AC, and ground. Impedance is 1 mega ohm plus or minus 2%. Probe attenuation 110, 100, 1000. Maximum input voltage 400 volts. Bandwidth limit 20 megahertz. Sampling rate 0.25 SA per second. Samples per second to 250 mega samples per second. Interpolation is sin X on X. Sweep speed range 5 nanoseconds per division to 1,000 seconds per division. 125 stepping. Time-based accuracy is plus or minus 100 parts per million. Record length single channel 8K, that's not a lot. Sensitivity 10 millivolts per division to 10 volts per division with a displacement of plus or minus 6 volts. Okay. Analog bandwidth 70 megahertz. Low frequency response is about 10 hertz. And a rise time of about 5 nanoseconds. DC gain accuracy 3%. And now, for the moment you've all waited for. What's in the bag? Well, we hope it's a oscilloscope, right? Oh yeah. So we've got a charger, 5 volts at 2 amps. And here's the device itself. Wow, that feels substantial. That's large. That's bigger than a Fluke 87, but I like it. Okay, here we go. On the side over here. Alright, come on. I don't have fingernails, so this doesn't work. There's our probe compensation and USB-C charging port. On the top, we have channel 1, channel 2, and generator out. Man, if this thing's got a function generator, I'm going to be super excited. Got it powered up. I know it's not very bright. We'll see if we can't figure that out and get a better way for you guys to look at it. Alright, I'm going to charge it up. Before I do, let's see what else is in the box. We have a set of multimeter probes, BNC to alligator, USB-A to USB-C. Yep, that's everything we got. Oh, we got 2 sets. BNC to alligator. That's interesting. Okay. This is a nut. Whoop! Bumped the camera. Sorry about that. This is a nice thick USB-C cable. So we'll plug it in up here on the power strip. Pop this guy open here. And we'll get her charging. We have a red light indicating charge. So I'm going to let that charge up to its full charge, and we will be back. Okay, we're fully charged. So let's hook up our probe. This is the OW3070 probe, 70 megahertz. And we'll hook it up to channel 1. And we'll attach it to the probe compensation output. And we are properly compensated. Well, close. Let me adjust just a little bit. There we go. Not looking too bad. I know you're having a hard time seeing the screen, but help if I block the light a little bit. Yeah. Let me turn those big lights out. So we are properly compensated. And you can see channel 1, which is our yellow channel, is 1 volt per division. So 1, 2, 3, about 3.3 volts peak to peak. And let's see. Measure on source channel 1. Add delete frequency. Now you can see we've got a nice little frequency there of 1 kilohertz. So what we're going to do next is we're going to hook it up to a signal generator and take a look at some of the signals it can produce. And when I say a signal generator, what I should have said was the signal generator right there on top. So hang on for that. Alright, so let's say mode, generator, waveform type. We'll go with the sine wave. And let's see how high of a sine wave we can get out of here. Megahertz. 2, 3, 4, 13. I'm impressed. 20 megahertz. Alright. Let's see what a 20 megahertz sine wave looks like. Put the auto set. Oh, I guess we have to turn it on. Oops, wrong button. Damn it, keep missing it. Damn it. Alright, sine wave. So, how do we turn it on? One moment. Okay, so the run stop button turns it on. Then we'll hit our auto. That says 1 megahertz. That is 1 megahertz. Let's have a look at 25 megahertz. Megahertz. Looks good. We're at 10 volts per division. 10, 20 volts. Is that what I had set up there? No, I've got 3 volts peak to peak. Let's put this at 1 volt peak to peak. And then we're going to need to channel 1 vertical scale. There's 2 volts per division. There's 1 volt per division. Now how do I adjust company's probe? There we go. 1x. Try to auto set it again. And alright, so there's 1 volt per division. We're at 1 volt peak to peak, so that's looking good. Let's go in here and go take it up to 5 volts peak to peak. 1 volt per division. 1, 2, 3. That's peak to peak. Okay. So that's looking real good. Let's see some of the other waveforms. Square wave. Five megahertz. How fast can we go? That's it. 5 megahertz on the square wave. Let's take it down to 1 megahertz. And we'll go 1 volt peak to peak. Whoops. With a 1 volt offset. Now we'll change this 200 megavolts, or 200 millivolts per division. And horizontal time base. Yeah, that's looking real good. You can see our sampling here is at 250 megasamples per second. Not fantastic, but for a handheld scope, yeah, that's looking pretty good. All right, let's take a look at the multimeter side of it. All right, as is our custom here, we are using the Probe Master gold-plated probes. All multimeters are tested with the same set of probes, so any difference that we see is simply in the multimeter, not a function of the probes. Voltage DC, voltage AC, current, millivolts. Let's see what we get here. So, let's see if we can get some resistance, huh? We should start out with it's about 0 resistance. .07 ohms. All right. Okay. So we're going to use this little resistor board. I'll get it hooked up here. And we'll see how well it reads resistances. I'm sure it'll be just fine. The only real thing to test here is kind of the speed in doing it. So right now we are on 0 ohms and we're showing 2 ohms. Is there any way to zero this out? I don't see anything. Alright, let's try 10 ohms. Oh, knocked one of my wires off. I'm like, why am I not getting a reading? So with what we have there before, close enough. Let's try 50 ohms. Good. All right. Try 100 ohms. Okay. Let's try 500 ohms. I like how you can see the range is switching there. It's very nice. Alright. Let's do 1K. Close enough, man, that's good. Here is 7K. Yeah. That's good. 10K, 90K. Good. 100K. Oh, is that on there? Yeah. 400K. Yeah. 900K. Oh, it's 800, sorry. Good. 1 meg. Yep. 6 megs. Yep. 10 megs. Or 9 rather. Let's add another 9. Ooh, or that's 100K. 9.1? 9.9 rather. Yeah. And you can see there where I got it hooked up. 9. I bumped something, that's why the numbers are going wacko. Alright, let's try capacitance. Alright, as you can see, I'm using my little capacitor board. We got it at 22 nanofarads. We're reading 25.5. That's fine. Let's go to 10. 10 nanofarad. We were on microfarad before, I'm sorry. 9.9, all good. 10 picofarads. I'm not reading the 10 puff. 22. Yeah, there we go. Good. All right. Let's test continuity. I'm going to take these mini grabbers off here. Those are like one of the most useful accessories you can get for a probe. Set of probes are mini grabbers. All right, here's continuity. Let's give it the old Dave Jones. Yeah, it's good. No worries whatsoever. Let's go to diode testing. Okay, diode testing. We've got LEDs and some other diodes here that we're going to have a look at. So, let's start with a red. Perhaps I'm backwards on it. Can't really tell there because it's too far away from me. Huh. Not getting anything at all off the red. Excuse me. Need to figure out which side is the anode and which side is the cathode. Alright, so anode is to my right. Let's see what we get. Oh, there we go. As you can see, it lit the LED, and we're getting about 1.8 forward volts. Next up, yellow. Once again, it's lit. 1.84. Next up, we have green. Lit. But that's over 2 volts and it can't read it. Blue. Lit. Can't give us forward voltage reading. And white. Lit. Can't give us forward voltage reading. So it's probably outputting about 3 volts, which is enough to light any of those LEDs. But it can't read any forward voltage drop over 1.8. That's a little odd. Alright. Schottky diode should have a forward voltage reading of about 0.2. And a silicon junction somewhere between 0.6 and 0.7. Good. No worries whatsoever. Thing's absolutely solid. And you notice here we also have DC voltage, DC current. And it tells you to make sure to connect correctly. We'll go back to DC volts. Now we're in AC voltage. Well, let's see if we can blow it up. I'm going to plug it into main. Should be about 123.5 volts for today. Ooh, we're high today. 125.05. Hell doggies. Thanks, American Electric Power. I appreciate the extra 2 volts. I'll put them to good use. Alright, we got the voltage standard running. This is DC. We're outputting 10 volts. We're getting 10.009. And you know what? That's close enough for government work. 7.5. Right on, right on. 5.014. Looks good. And 2.5. We got 2.506. I call that right in the pocket. No worries about this at all. As a multimeter, I really like it. The screen is large. It's easy to read. The screen is 3¼ inches wide. For you continental types, that would be 88 centimeters. It is... I'm just going to measure the usable part of the screen here. 2.5, or, for those of you who have yet to land a man on the moon, and that is a joke. Don't get uptight about it. Well, how did I measure that before? Because I didn't do it right. Yeah, the usable part of that screen vertically is 1.5 inches. And in metric, excuse me. All right, let's check some low DC current. And for that, I've got this neat little toy. The Finercy SG003A. So, right now it should be outputting 4 milliamps. Let's find out, shall we? Milliamps. There we have it, 4 milliamps. Can we take it up some? 5, 6, 10 milliamps, 20. That's our max. Right on. No worries at all. Yeah, I like it. What do you say we lift up her skirt, see what kind of plumbing she's sporting? It's always fun, right? This is our battery compartment in most multimeters. Hard to say what it might be in this guy, right? It is, aha! 18650s. I am surprised. I was expecting a flat pack in there, but I like this so much better. This means you can replace them. And replaceable batteries, assuming you don't blow this up, spill anything in it, you know, drop it from your homemade helicopter. It's probably renewable for just about ever. To avoid electrical shock, remove test leads before opening case. We got little self-tappers going into plastic. You know, par for the course. Brass inserts would have been nice, but you know, that might have been a little cost prohibitive in the manufacturing process. And actually, they were supposed to send this out to me like 2 months ago. And then they called me up, or messaged me rather, and told me it wasn't quite ready yet. So I wonder what they ended up doing to improve it or whatnot. There we are. Okay. Just looking it over here. .324 of 2021. This is the HDS200 mainboard version 2. What do we see? Well, there's our current shunt right there. Little brass guy. There's our fuse. We got a couple of melts. We got a PTC. This appears to be, yeah, it's marked F2. That's a fusible link. Got a 4 megahertz crystal. Opto isolators. You don't often see that. Look here. Look at his header. They even labeled it. 3.3 volts. TRST TDI JNS 100 NR. I have to put my optovisor on. I'm too blind. Perhaps you guys can read it. Oh, I can read it here. I can just look at the camera, huh? 3.3 TRST TDI JMS CLK TDO, and NRST. So if you wanted to hack it, that's probably where you'd do it from. What else do we see interesting here? That little guy right there is a quad flat pack. So chances are that's a microprocessor. There's something written on it. I can't quite tell. Let's finagle the camera. Alright, what's it say? You can probably read that better than I can. There you go. About as close as I can get you. And the last question is, did I kill it when I took it apart? I did not. So again, we've got a 2-channel 70 megahertz oscilloscope, a full-featured multimeter, and a function generator. These are going anywhere from $120 or so at this time. I know it'll go up once I publish this video. I'm sorry. What happens is you guys look at the links, they see a lot of links being clicked, and they know there's interest in the product and they raise the price. I can't help it. I've seen them as high as about $180 on Amazon US. So, you know, if you can wait a couple months to get one, you can get one for a little over $100. If you're like me and you can't wait, it's going to run you about, you know, $200. It's a great value. I like it. If you're building yourself a little home electronics lab, while I would recommend a separate multimeter, oftentimes you want to measure voltages or measure current while looking at a waveform on the oscilloscope. This will get you going, man. This will save you a couple $100. So, yeah. Thank you very much to Owon for sending this out for our consideration free of charge. Thank you for watching. Thank the patrons for making this channel work at all. Without them, we just couldn't do this because I wouldn't have been able to retire from teaching early, and I would still have to work full time, which means wouldn't be able to bring you 3 videos a week. So you have my thanks. All right, feel free to like, comment, don't forget to subscribe. That's it. I'm out. Peace.